on an everyday basis. I think that you have been exposed more to AI. I still think our countries in global south are not necessarily at that level.
Millions of farmers can only dream of robots working in fields. But in China, it's already happening. Farmers there are using smart machines that work faster and longer than humans. While United States farmers still rely on people for most tasks, China is racing ahead. Could this change the future of farming worldwide? Join us as we discover how these machines could improve agriculture. China's farms are entering a new era of technology, where intelligence and automation transform the way food is grown and managed. Machines move across fields tirelessly, adapting to changing conditions, monitoring growth, and optimizing yields while reducing human labor. With networks of smart devices and automated systems, farmers can make instant decisions, increase output, and respond to challenges faster than ever before. Here are some of the most interesting and advanced agricultural mechanization so far. Number 8. The Titan Harvester. In China's modern fields, farmers are increasingly using homegrown agricultural machines that match or exceed the performance of foreign harvesters. One of the biggest names in this area is Lovol, a major Chinese agricultural machinery brand that has been pushing high-capacity, intelligent harvesting equipment into large-scale farming. These machines feature powerful engines, advanced threshing systems, and large feeding capacities that set new standards for what Chinese-built harvesters can do. Lovol's harvesters are designed to handle massive amounts of grain quickly and with high efficiency, helping farmers bring in wheat, corn, rice, and other crops at harvest time without losing quality. Modern combines from China often use axial flow threshing technology, a method where crop material flows through a drum and concave system that separates grain from straw smoothly and with low loss. This type of threshing is widely used in international agricultural machinery and has been adapted in Chinese models to improve throughput and reduce breakage even under heavy load conditions. Many new harvesters are built to feed grain into their systems at high speeds, while ensuring that cleaning and separation remain effective across different crop types. Chinese manufacturers are also adding smart features usually found in the latest global machines. Sensors inside the combine collect real-time data about crop conditions, moisture, and throughput. These systems can automatically adjust machine settings, such as drum speed, sieve openings, and fan airflow, to match what the field actually presents, helping reduce grain loss and improve overall harvest quality. This automation moves Chinese harvest technology closer to precision agriculture. Connectivity with other farm vehicles is another area of growth. Some Chinese harvesting fleets are now designed so that grain trucks or unloading wagons can operate alongside a moving combine, allowing farmers to transfer grain without stopping. This coordination reduces downtime in the field and keeps harvest operations moving efficiently, especially when weather windows are short. Beyond big combines, Chinese companies produce a wide range of harvesting equipment for different farm sizes and conditions. State-owned and private manufacturers supply self-propelled harvesters with varying capacities, as well as crawler and wheeled models suited to different terrains. All of these machines contribute to China's broader push toward mechanization and smart agriculture, transforming traditional harvesting into a high-tech process that improves food production across the country. Number 7. Weed Hunter Laser Bot. In recent years, farmers have started to move away from spraying herbicides over entire fields to control unwanted plants. In China, researchers and companies have been working on a very different idea, using robotic machines with lasers to find and destroy weeds without damaging crops or soil. These robots combine artificial intelligence, computer vision, and laser technology to identify and remove weeds in a cleaner, more efficient way than traditional chemical methods. One of the most advanced examples of this technology is the laser weeding robot being developed and shown by technology firms in central China. These robots are built to operate around the clock in real farm fields, using high-resolution cameras and AI systems that can tell the difference between crops and weeds. The image systems are trained with thousands of examples so they can recognize many kinds of plants as they move through a field. Once the robot detects a weed, it doesn't spray any poison. Instead, it uses a focused laser beam to heat and dry out the weed's internal cells, causing the unwanted plant to wither quickly. The intensity of the laser can be adjusted automatically based on what the AI system sees, so the machine avoids harming the crops it is protecting. This process happens in a fraction of a second after the robot spots a weed. In tests, the most advanced versions of these robots have shown they can remove large numbers of weeds every hour, dozens of times faster than humans with herbicide sprayers or hand tools. Some machines have many laser emitters working at once, allowing them to target hundreds of thousands of weeds per hour while moving steadily through the field. Because no chemicals are used, this laser-based approach helps prevent soil and water pollution that can come from repeated herbicide use. It also cuts down on the cost of buying chemical weed solution and reduces the need for farm workers to spend long hours in the fields pulling weeds by hand. Field trials in different provinces have shown that these robots can work in varied crop conditions and lighting, helping farmers manage weeds more efficiently and sustainably. Number 6, the Sky Striker. From the sky above big farms in China, powerful crop care machines are changing how fields are tended. One of the most capable models is the DJE Agri's T60 agricultural drone, a large unmanned aircraft built to carry heavy loads of liquid and solids and work over many hectares of land. These machines are engineered with strong motors, high-strength propellers, and smart systems so they can fly long missions carrying up to around 50 kilograms of pesticide liquid or up to 60 kilograms of seeds or fertilizer for spreading in one flight. The T60 has a high-capacity spraying system that delivers liquid medicine or nutrients at a high rate and wide swath, helping cover large crop rows quickly. Tanks on this drone can hold about 50 liters of liquid by default, and there are options to go up to 60 liters for heavier spraying work. Even the spreading system for seeds performs well, moving hundreds of kilos per minute across a broad section of ground. One interesting feature of these machines is their sensing and safety technology. The T60 and similar agricultural drones use advanced radar and camera systems that work together to see obstacles like utility poles, tree branches, wires, and other hazards. The active phased array radar system can detect objects in all directions up to tens of meters around the aircraft, while cameras give a wide visual field so the flight computer can adjust the path and keep the drone flying safely. Because of these sensors, the drones can fly very close to the crop canopy even at night or in low light, adjusting height and direction automatically to avoid hitting anything that might be in their way. Operators on the ground don't have to manually guide every movement. Instead, they use a tablet or remote display to plan routes and watch progress while the intelligent software handles detailed flying and obstacle avoidance. The effect on traditional field work is drastic. What once took many farm workers a full day of walking, carrying heavy equipment, and applying sprays or seeds by hand can now be handled in a small fraction of that time. A team might spend hours trudging under hot sun, but a swarm of these drones covers large areas in minutes with precise control over how much material they release and where. Number 5, the rice runner. Across China, huge advances in farm machines are changing the age-old way of planting rice into a process that looks nothing like the hard work it used to be. In the past, people spent long weeks bent over muddy fields, placing each rice seedling by hand. Today, farmers use intelligent rice transplanting vehicles that can drive themselves across water-filled paddies and place young rice plants into the soil much faster than a team of workers could. These machines are designed with modern guidance system so they can steer accurately and work long hours without tiring. The new autonomous transplanting equipment moves smoothly across the wet field surface, lifting its wheels without digging too deep or getting stuck. Instead of depending on what a driver sees, the machines tap into China's own Beidou navigation satellite system, which works like a GPS with very high precision. The transplanters can follow straight, perfectly spaced paths in flooded rice fields, even when there are no clear visual markers on the ground. They plant each seedling at exactly the right spacing, so that the rows stay neat and uniform. These smart systems also make decisions in real time, based on the conditions of the mud in the field. If the soil is softer in one area, the machine adjusts the depth it places seedlings, helping all the plants be set at the best depth for strong growth. The precision of these operations means the plants are placed with very small margins of error, often within a few centimeters for row spacing and depth, which helps maximize the use of every square meter of field. One farmer in Heilongjiang province explained that one machine could handle what once took many people and days of work, finishing large areas in far less time. While the transplanter works automatically, the farmer can monitor and control it from a tablet or smartphone, checking routes and progress without staying right next to the machine. This frees the farmer to rest or do other tasks while the machine keeps moving. In many regions of China, fleets of these autonomous planters now work side by side with drones and other smart machines, forming a fully connected system of high-tech farming equipment. This new wave of agricultural technology not only cuts labor demands, but also helps farmers plant at the best times, use land more efficiently, and aim for better rice yields each season. Number 4. The Green General. In northern China's dry lands, engineers are using machines instead of people to plant windbreak forests across sand and bare soil. These areas in Inner Mongolia and nearby regions used to be hard, hot, and almost empty, where ordinary workers could only plant a few trees a day by hand. But in recent years, new intelligent tree planting machines have been developed that can go out into the dunes and work like automatic crews on a huge scale, helping slow down the movement of deserts. These smart machines are designed to work in conditions that would be too hard for a human, with systems that soften the soil, insert saplings, and cover them again in seconds. They use mechanical augers, like strong drills, to loosen the hard desert surface, then place the young plant into the ground, water it, cover the base, and press the sand around it so it stands firm. One operator can run the machine remotely, and each planting action takes only about 5 seconds from start to finish. Connected to weather data and remote controls, the robots know where to plant and how deep to place each young tree for the best chance of surviving dry heat and shifting sand. They can run for long hours in open sun and wind without tiring or needing breaks, doing work manually that once took dozens of people many days to complete. These machines are part of China's decades-long 3 North Shelter Belt Forest Program, also called the Great Green Wall, which began in 1978. The goal is to plant forests and greenbelts across the north of the country to slow deserts like the Gobi and Mu'us from spreading southward. With machines and people working together, China has planted trees on millions of hectares of formerly bare land, building long lines of windbreaks and shrubs along sandy edges. Around these machines, other technologies are also used. Drones fly overhead carrying seedlings to remote or steep dunes, and local teams weave straw grids into the sand to help steady the ground before trees are planted. These grids act like tiny fences that catch blowing sand and trap moisture, giving young trees a better environment to grow in when they are first placed in the soil. Because the desert control machines work faster and with more precision than manual planting alone, they cut labor costs while increasing the number of saplings planted each day. In some project areas, robots do 10 times as much work as people for a much lower cost, helping establish vegetation faster across many square kilometers of sandy land. The combination of intelligent machines, drones, advanced planting techniques, and deep planning has transformed how China approaches desertification. By using machines to plant in places too hot and harsh for manual crews, the country is turning huge sandy regions into productive green belts that help protect farmland, prevent soil loss, and build new forest cover along what was once barren desert. Number 3. The Hog Tower. Up on the edge of a city in central China, a massive concrete tower rises above farms and fields. Instead of offices or homes, this 26-story building is filled with rows of pens designed to raise pigs. The structure is part of a new breed of mega farm built by Hubei Zhongxin Kaiwei Modern Farming, and it is one of the biggest single-building pig farms in the world. Together with a sister building under construction, it will have space for up to about 650,000 animals. Inside this giant high-rise, pigs live on floors stacked on top of each other, from young piglets to fully grown hogs. There are thousands of individual pens arranged along each floor, and animals are moved by lifts and pathways between levels. The design puts far more livestock into one vertical space than a normal flat barn could, and planners say this makes the farm more efficient with the land it uses. Everything in the building is tightly controlled by machines and computers. The temperature, gas levels, and ventilation in each part of the structure are kept within set limits to keep the animals healthy. Food is delivered automatically to more than 30,000 feeding points with the push of a button in a central control room, allowing operators to manage feed for hundreds of thousands of pigs without constant human labor in the pens. The farm also collects waste from the animals and turns it into biogas, a form of energy. This gas can be used to produce electricity or heat water inside the building, helping reduce the need for outside power and lowering waste that would otherwise pollute the ground. Because the pigs are raised entirely indoors, strict disinfection and biosecurity are also part of the routine. Workers must pass through multiple sanitization stages before entering to avoid bringing in viruses or germs that could spread among the animals. However, the scale and intensity of this operation have drawn debate. Some animal rights and environmental critics worry about the well-being of animals in such concentrated conditions and the risk that disease could spread rapidly if it enters the system. Still, developers of the project say this form of vertical farming is a response to China's huge demand for pork, which is the most eaten meat in the country. Farms like this aim to stabilize pork supply and keep prices from swinging widely. Number 2. The gentle gripper. In many Chinese farms and greenhouses, new machines are taking over the hardest part of growing fruit, picking it. For a long time, farmers struggled to build robots that could grab soft fruit without squeezing it too hard or bruising it. People knew that if a machine pressed too firmly, the fruit would get damaged. And if it held too loosely, the fruit would fall, which made building a good robot very difficult. However, recent advances in robot vision and gentle grippers are changing that. Today's picking robots use artificial intelligence and machine vision systems to see fruit in 3 dimensions and decide which pieces are ready to be picked. At a major agricultural technology fair in China, visitors saw robots that use deep learning algorithms to look at fruit color, shape, and size, decide which ones are ripe, and then guide a robot arm to pick them. The vision system helps separate ripe fruit from leaves, stems, and branches, so the robot can plan the best path to grab each one. Some of these machines are designed with soft or flexible picking tools that can handle delicate crops like strawberries, tomatoes, and other fruits without breaking the skin. One type of robot developed in China is equipped with patented grip technology and advanced vision software that looks at color, size, and quality of fruit and picks only the best ones, reducing waste and protecting delicate produce from damage. These systems also let the robot move by itself between rows and avoid obstacles as it operates. In practical tests with tomato picking robots, machines using AI vision and soft suction grabbers were able to pick ripe fruit with a high success rate and almost no bruise marks, sometimes less than 0.4% damage, even under complex greenhouse lighting and shadows. Farmers have reported that this consistency is especially valuable for fruit sold in premium markets. And stores are even offering labels for robot harvested produce because it stays fresh longer. The robots also get smarter over time. They can be updated with new software so their vision systems learn to find fruit more accurately under many conditions, including when light changes or leaves cover fruit. Instead of needing people to correct every mistake, the robots improve their ability to spot and pick fruit as they work. This lets farmers rely on machines that can work day and night without getting tired, without needing breaks, and without hands getting hurt by thorns or branches. Because these robots are becoming better at delicate work, they are starting to replace temporary workers in big greenhouses, especially in fruit-producing regions like Shandong Province, where large volumes of strawberries and tomatoes are grown. Robots help ensure fruit reaches shops with very few bruises and almost no human touch before it's packed, helping keep prices more stable and quality more consistent. Number 1, the turbo tractor. Across many Chinese farms, new types of tractors are working in the fields without any person on board. These machines look very different from the old tractors with cabins, seats, and wheels that farmers rode in. Instead, today's self-operating tractors are designed so a human does not sit inside them at all. They carry powerful electric motors and computers that let them move and work on their own without any driver. One example is the Honghu T70, a fully autonomous electric tractor developed in China to help with major farm tasks like plowing, sowing seeds, caring for crops, and even harvesting. The machine runs without anyone inside, guided by advanced navigation systems. A strong lithium battery gives the power, and the machine can work for many hours at a time without stopping. It also uses 2 separate motors, one to move the vehicle and the other to operate the farming tools attached to it. The most important part of these new tractors is how they find their way across large fields. Instead of needing a driver to steer, they connect to China's Beidou navigation satellite system and often use additional sensors and smart control software. These systems give very precise location data, more accurate than older generation GPS, So the tractor travels in almost perfectly straight lines and places tools exactly where they need to go, while plowing or seeding. These tractors also use 5G network connections and smart AI software to respond to changing field conditions in real time. They can collect data about soil quality, moisture, and crop growth, then adjust what they do to suit the ground better. This real-time decision-making helps them avoid obstacles, keep to their planned route, and take care of tasks even when weather or soil conditions change. Because these machines are autonomous, the role of human workers is changing. A farmer can program the route or task list from a tablet or smartphone and then watch the machine do the work. There is no need for a steering wheel or seat because the computer and navigation system guide every movement. This shift means farmers spend more time planning and managing the machines instead of physically driving them through fields. New electric and autonomous tractors are now being used in places like Hebei province and other agricultural regions of China. They are part of a broader wave of smart farming technology that includes satellite support, sensors, artificial intelligence, and high-speed networks, all designed to improve productivity and reduce the need for manual labor in fields across the country.